Hi everyone, this is Mrs. Rondo. I'm going to walk us through how to do the problem with the multiple parts for our 3.1 quiz. So this is the answers to the quiz practice. So here we go. The first part is the scatter plot below shows the fuel efficiency in miles per gallon and weight in pounds of 20 subcompact cars. And so we're going to jump right in. There's our scatter plot, and we're going to answer some questions. Is there a clear explanatory variable and response variable in this setting? So they didn't give us a clear statement about whether there's explanatory and response variables. Based on the scatter plot, we could assume that, let me get my pen going here. We could assume that the explanatory variable is the x. So that would be car weight. So explanatory variable is the car weight. Don't mind the background noise. Let me try that again. Car weight. Awesome. And then if that is our explanatory variable, again, because it is the x, or what we're going to use to help us explain or understand fuel efficiency, that would be our response variable. So the response variable is fuel efficiency. And again, that's acting as the y. And then to give a little bit of our reasoning here, just to kind of make sense of this, we would expect a car's weight to affect, there's that keyword there, affect, or one of our keywords we talked about, affect, predict, those types of words. We would expect the weight of the car's weight to affect its fuel efficiency. Awesome. All right. Then part B. So we're just going to go through and do each question. For part B, does the scatter plot show a positive association, negative association, or neither? And explain why this makes sense. This one appears to be negative, although it's not extremely slanted, but it is a negative association. So we could say the association with a nice line through it. That's fantastic. The association is negative. Perfect. And how it makes sense. We could say this makes sense. Because remember, the whole thing with negative association is one thing gets bigger as another thing gets smaller. So in this case, as our car weight increases, it's less fuel efficient. It uses, or it goes less miles per gallon. So we'd say this makes sense because the heavier the car, heavier, I can't spell heavier. Sorry, a lot of pausing to write. Heavier the car, the less miles are traveled per gallon. Or a slightly different version of looking at this You could also talk about it in terms of it takes more fuel to move a heavier car. I might just write that down. It takes more fuel to move a heavier car. That's why we're getting the less miles per gallon. Okie dokes. Car. There we go. On to the next one. All right, this one. How would you describe the form of the relationship? So when we're looking at form, that's whether it's curved or linear or, some clustered, anything like that. In this case, it does look very linear. So we would say, how would you describe the form? It is linear. And then there is one thing, though, that we should comment on at some point in all this, and that is it seems we have a really random outlier up here at the top. So it is linear with the exception. That's like the main exception to the linear rule. With the exception of one outlier. Awesome. Next one. All right, part D. Which of the following is closest to the correlation car weight and fuel efficiency for these 20 vehicles, and explain? So we already mentioned that the association was negative, so we definitely would not choose one of the positive numbers if we already said it's a negative association. So then the question is it strongly negative or kind of moderate? Remember, strongly would be close. So I'm going to just make a note here. Strong is close to 1 or -1. And we have moderate is kind of like 0.5 or -0.5, somewhere around there, depending on whether we're on the positive or negative side. And then weak is going to be our close to 0 numbers. So looking at the two options that are left, the -0.9, that would be saying that it's a strong. So this one right here would be talking about a strong association, and this one would be saying kind of a moderate. And so based on some of our practice here, that looks very linear. So I would say it's the R equals -0.9. A -0.6 would be quite a bit more spread out. And again, if you're struggling to make sense of that in terms of what the R values look like, definitely check out that link to the game, because that's a good way to practice. All right, I didn't finish writing this. Moderately, sorry, strong is close to, figure out what I was trying to write here. Strong is close to 1 or -1, moderate 0.5 or -0.5, and then we have weak is close to 0. There we go. Just get all those things on there so we can clearly see all the stuff in one shot. Fantastic. Next one. E. There is one unusual point. We mentioned it. That's our outlier. It's kind of what it means to be an outlier. On the graph, explain what is unusual about this car. So what would be unusual about it is it has a higher fuel efficiency than any of the other cars. So this car has not just a high efficiency, but we might even say a remarkably high, noticeably, extremely, something like that, remarkably high. Again, that's this point up here. Fuel efficiency. Um, and then I might just comment, explain what's unusual about the car. That's what's unusual. It has a remarkably high fuel efficiency. But in terms of explaining it, my guess superimposing thoughts into how do we get a car with that high fuel efficiency that this, I would say a comment, this car is most likely a hybrid. Either it's a hybrid, probably a hybrid. Meaning gas electric. There you go. All right, last one. What effect would removing the in let me try that again. What effect would removing the unusual point have on the correlation? Justify your answer. So that particular point is super high, and it's super high, but specifically way far away from the pattern that we have. So when we have a point that is not following the pattern, that usually makes our correlation um, weaker or closer to zero. So if we take that point out, it should make our correlation stronger. So it should be, in this case, closer to -1 because we have a negative association. So if we remove the outlier, the correlation will sorry, I'm trying to think about how I want to say that. Correlation will get closer to -1. Yeah. So if we move the outlier, the correlation will get closer to -1. We could even say because the pattern of the scatter plot will be more consistent. So there you go. That's a little bit of an explanation, although it doesn't necessarily ask for that, but that's kind of why. So again, talking about outliers, if the outlier fits within the pattern, it will make the correlation stronger or closer to a linear form, either closer to 1 or -1. And if it is not within the pattern, it will make the outlier makes the correlation weaker or closer to 0. So when we take it out, it does the opposite. There you go. That's everything for. Oh, I might have lied. I'm so sorry. We have one more question. I apologize. I did not even see that there. There it is. Sorry about that. One more. If we converted the car weights to metric tons, so 1 metric ton equals 2,205 pounds, how would the correlation change? Remember, so first of all, correlation doesn't have units. And changing the units doesn't change the correlation. Okay, so change, since correlation specifically is because correlation has no units. Let me say so instead of and, let's say so, changing the units would have no effect. There we go. That should be the end. Have a good night, everyone. Adios.